once you have decided that you are going to design on the balance condition, this is how the beam will fail. So for over-reinforced, meaning the failure is sudden, there will be a brittleness in the property of the concrete. There is a crushing of concrete, nagkakaroon ng disintegration in the compression zone, at while the yield point of the steel has been not yet achieved, and therefore, to prevent this, the steel reinforcement should yield first before you achieve the concrete strain of 0.003. While for the under-reinforced, the failure is brittle, nagkakaroon ng tensile stress sa concrete versus the modulus of rupture, nagkakaroon ng concrete cracks, immediately nare-release yung tensile force, nagkakaroon ng additional stresses dun sa lightly stressed steel, nag-i-snap yung steel, and ultimately magre-resulta sa total rupture. In the balance condition, however, which is the only acceptable condition in the design, there is a minimum and maximum value based on the codes and specification for the moderate percentage of steel. So there is a relatively low yielding of steel and low strain in concrete. So meaning there is a large deflection before final collapse, and the failure mode is ductile. So yung property of ductility na a-achieve natin. Again, this is the only acceptable mode of failure for reinforced concrete beam. So what happens in steel for a rectangular cross section such as this one? So if you would notice here, we have a rectangular beam. Ito yung width ng beam natin. This is the effective depth. I would also reiterate, we are designing based on the effective depth. Okay? So the effective depth is measured from the center of the steel reinforcement to the extreme compression fiber. We do not consider in the structural design the concrete cover. So the concrete cover only serves to protect the reinforcement, but it has no structural function at all. So if you are going to draw the strain diagram for beam, this will be the strain diagram. The beam will achieve 0.003 maximum concrete